Good morning. Today I am going to discuss about dinuclear metal clusters of rhenium. The best studied metal cluster species are Re2 Xi2- ion. They may be prepared by the reduction of perrhenate ion ReO4- with H2 H3PO2 or PHCOCl in the presence of HX. The reaction will be 2ReO4- H with H3PO2 in the presence of HX to form Re2Xi2-, where X will be chlorine, bromine, iodine, isothiocyanate. The most interesting facts about Re2Xi2- is its structure. There will be two unusual properties. The first one will be the extremely shorter Re-Re bond distance, which is equal to 224 picometer compared with an average Re-Re distance of 275 picometer in the case of rhenium metal and 248 picometer in the case of Re3Cl9. The second unusual feature is the eclipsed conformation of chlorine atom. Cotton described the bonding in Re2Cl8- ion using delta bond concept. There will be some assumptions about the delta bond concept. The first one will be the z-axis of Re2Cl8- ion is taken as the line joining the two rhenium atoms. The second assumption will be each rhenium atom is surrounded by 4 chlorine atoms in an square planar array in which rhenium atom is 50 picometer out of the plane to the 4 chlorine atom. The third assumption will be each ReCl bond on each metal atom undergo dsp2 hybridization, for which the dx² - y² orbital is used. The fourth assumption is the metal dz² and pz orbital is taken as the bond axis, which may undergo dp hybridization to form two orbitals, one of which is oriented towards the rhenium atom and the second one is oriented to the opposite direction. This implies the formation of a sigma bond in which the former can overlap with the similar orbital on the second rhenium atom to form a sigma bond, and the second orbital remains as the non-bonding orbital, in which these are the two rhenium atoms. And this portion explains about the dp hybridization or the formation of sigma bond using the dp hybridized orbital. These are the two non-bonding orbitals. Then we are going to see about the formation of two pi bonds, for which the dxz and dyz orbitals are used. By the productive overlapping of these two orbitals, we get two pi bonds in the xz plane and one in the yz plane. This implies each rhenium atom has the two orbitals dxz and dyz. Both orbitals are oriented obliquely towards the counterpart of the similar orbital on the second rhenium atom to form two pi bonds. The first pi bond is in the xz plane using dxz orbital, and the second pi bond is in the yz plane using dyz orbital. Then we are going to see the delta bond formation using the remaining dxy orbital. The sidewise overlap of the dxy orbital results in the formation of this delta bond. Positive overlapping results by the eclipsed conformation of chlorine atom. If the chlorine atoms are in the staggered conformation, there will be zero overlapping. Here, the eclipsed conformation of chlorine atom results in positive overlap of dxy orbital to form delta bond. Here the chlorine atoms are in staggered conformation. Here there will be only 0 overlapping. The total of 8 electrons on each rhenium atom occupy 1 in the sigma bond, 2 of the pi bonds and 1 in the delta bonding. Hence, these 4 bonds forms the quadrupole bond. Hence, Re2Cl8 is diamagnetic. By these assumptions, Cotton rationally successfully accounts for the strength of the bond, extremely shorter Re distance and the quadrupole bonding in Re2Cl8 2 times. Then we are going to see about dinuclear cluster complexes of copper 2 and chromium 2. Copper 2 and chromium 2 are first transition series elements, forms acetate complexes similar in structure with the rhenium carboxylate complexes. As like in the rhenium complex, the copper 2 and chromium 2 complexes are also diamagnetic, indicating that the spins are paired. This will be the molecular structure of copper 2 and chromium 2 complex, where there will be the metal-metal bond. N2RCO2 4 times will be the general formula, where M will be copper or chromium. When the metal is chromium, the chromium bond distance is 236 picometer. Or when the metal is copper, the copper bond distance is 264 picometer. The copper bond distance in the case of copper 2 complex is 264 picometer, which is somewhat longer than the copper distance in the case of metallic copper, where there will be the bond distance is only 256 picometer. But in the case of copper 2 acetate, there will be only weak single bond formed by the pairing of odd number of electrons on each copper atom. In the case of chromium, that is chromium as the metal, in the case of chromium 2 acetate, the chromium bond distance will be 236 picometer, which is somewhat shorter than the bond distance in metallic chromium, where the bond distance is 249 picometer. All these evidence and orbital symmetry corresponds to weak quadrupole bond in the case of chromium in chromium 2 acetate. Also, the bond strength in chromium bond is somewhat stronger than that in the copper bond. Then we are going to see other dinuclear clusters of rhenium. Rhenium 3 forms a large series of carboxylate complexes which are similar in structure with Re2Cl8 ion of formulas Re2RCO2 4 times X2 and Re2RCO2 2 times X4, which are in extremely short Re bond distance, eclipsed conformation and quadrupole metal bond. These two formulas are similar in structure with Re2Cl8 The only difference is that the ligand overlap with the metal dp orbital, which were non-bonding in the case of Re2Cl8 This will be the molecular structure of Re2RCO2 4 times X2, where rhenium bond distance is 220 picometer, where the X will be chlorine, bromine or iodine. This will be the molecular structure of Re2RCO2 2 times X4. Here the rhenium bond distance is 220 picometer. X will be bromine, chlorine and the L will be H2O.